Question 17 is about iteration. First of all, we've been asked to show that this equation can be written in this form. And then we've been asked to find a solution using our iterative formula to the equation that our original quartic here equals to 0. Okay, let's have a go. Our main problem in deciding how this has been transformed into this is to realize which x has been made the subject. And I think you can see quite easily that this guy must be the subject, because the last operation, obviously, to get x was to take the fourth root of x squared plus 5. So let's just do that. So if I take this result, so therefore make x to the fourth the subject, this becomes x to the fourth, and everything moves to the other side. So this becomes x squared plus 5. And therefore, x is equal to the fourth root of x squared plus 5. So that's answered part A. So in part B, we've got our formula that we've worked out here now modified into iteration form. In other words, this is an old value of x transferred into a new value, and you do that 3 times. Our starting point will be x0 is equal to 1.5. So we initially shove 1.5 in here, square it, add 5, and take the fourth root, and that becomes our new value. Now on a calculator, there is a really good method. We have to say 1.5 equals. And what that has done, it has put this into the answer location. So remember that 1.5 is in the calculator's memory for answer. So if you type this expression in with answer instead of 1.5, you'll be able to get a new answer. And that new answer will be x1. And the calculator will offer up an answer of 1.6409, and on it goes. Happily now, all we have to do is push equals again. And you get a value of x2 as 1.6653, and on it goes. Pushing equals again, I get x3 is equal to 1.6697, and on it goes. So the estimate for the solution of the equation x to the fourth minus x squared minus 5 is equal to 0 is indeed that x equals 1.6697, which is our last answer that we got through the routine. You see, each time we push equals, the answer gets better, gets nearer and nearer to the true value of the root. The more times you do it, the better this answer will be. We've just been asked to go round the mulberry bush just 3 times, and the answer we've got is this one. And that's the answer that should get you full marks.